Hi Algebra 2 students, this is Ms. Penn. This video is on properties of exponents, and I said review right here because this should be a review either from, even going back all the way to 8th grade, you started doing properties of exponents, and you should have gotten it in Algebra 1 as well. So you might want to pause the video for a moment and just copy down the chart that you see here before you. So we have like one column which is the property in general, and then for each property I gave you an example, and we're going to kind of run through these examples next. So before we start with the examples, if you press pause, create your chart, and then you can press play to begin the examples. So the first property we're looking at here is what happens if you have a base raised, this is a to the m times a to the n. So the bases are the same, but they have different exponents. When you're multiplying, you will add those exponents. So in the example, I actually gave you a little bit of a more complex example. It's not the most basic example because I think you're up for it since this is a review. So the idea is I'm going to be multiplying any numbers together, any x's together, and any y's together. So I'll start by doing the numbers. So that would be negative 3 times 5, which is negative 15. And then I have an x squared. I have an x squared here, and I have just an x, right? So that's x to the second times x to the first. So I would add an exponent of 2 with an exponent of 1, and I'd get an x to the third. And then lastly, I have y to the 7th and y to the 6th, so I do y to the 7 plus 6, which is 13. So I get a y to the 13th power. So this would be my final simplified form. I combined all the x's, all the y's, and I multiplied the numbers out front. I can't actually combine between x's and y's because those are different variables. Moving on to the next property is when you have a division of exponents when your bases are the same. So a to the m divided by a to the n is equal to, here we'll subtract the exponents. We'll get a to the m minus n. Okay, and in our example we have y to the 6th divided by y. Remember, if you don't see an exponent, that's like there being an exponent of 1. So then this would become y to the 6th minus 1. You don't necessarily have to write out that step, but it's pretty basic. You could do that in your head, and you get y to the 5th. Okay, sometimes you might get a negative exponent here, like if the exponent on the bottom is bigger than the exponent on the top. So that kind of leads us to needing a definition for what does it mean when we have a base raised to a negative exponent. So that's the next rule, a to the negative n. And we say that's equivalent to 1 over a to the n. So it's like the same base, same power, but it's no longer negative once you've moved it to the denominator. So if we look, actually wrote 2 examples here. First one is 2 to the negative 4th power. So the idea is the 2 would stay at 2, the 4 would stay at 4, and I'm just writing them in the denominator of my fraction without the negative sign. And I would just have a 1 on top, because there's no other exponents there, so I kind of use 1 as a placeholder. In the second example here, I have x divided by y to the negative 1st power, so that's a negative 1st power, it's not y minus 1. So the idea here would be that if the negative exponent's in the denominator, in order to get rid of it, I'd move it to the numerator. The x on top is going to stay an x, and then the y comes up top next to the x, so it'll be x times y to the 1st power. I don't even really need that 1st power now because it's no longer negative. So technically you could say this is over 1, but you don't really have to do that. You can just say x times y. Moving on to the next rule, we have a to the n to the mth power. So this is like a power raised to another power. And the rule here, you want to always be careful. This is different from the first rule because it's a power raised to a power. So in this case, we multiply. So we do a to the n to the mth is a to the n times m. And my quick example would be y to the negative 3rd to the 4th would be y to, what is negative 3 times 4? Negative 12. And then, just to keep simplifying, I could then apply the negative exponent rule and say that's the same as 1 over y to the positive 12th power. And that would be fully simplified. Okay, our next exponent rule is a times b to the nth power. If you have multiplication of two different bases raised to the nth power, both of those two expressions or variables or numbers, whatever they are, should be raised to that same power. So in my example, I have 2x to the third. The mistake would be to say that's equivalent to 2x to the third. But in reality, I have to take that 3 and it goes to both the 2 and to the x. So it would be 2 to the third times x to the third. Now I can compute 2 to the third is 2 times 2 times 2. 2 times 2 is 4, times 2 again is 8. So then this would be 8x to the third power. Moving along, we have a rule when we have a fraction inside and then erasing that entire fraction to a power. So a divided by b to the nth power. And it's a similar rule to the previous one in that the exponent outside the parentheses, it goes to the numerator and to the denominator. So it becomes a to the n divided by b to the n. I'm going to show you this example, which is actually a combo of this rule and the previous rule. So this rule says I'm raising a fraction to the negative 6th power, so that both the numerator and the denominator need to get that negative 6th power. So that might look like a to the, I'm just going to rewrite the numerator and then put that negative 6 right there outside, divided by rewriting the denominator raised to the negative 6. Now I'm not quite done because now I would have to apply the previous rule, the a times b to the n is equal to a to the n times b to the n, because I have an a and a b inside those parentheses getting raised to the 6th power. So that would look like multiplying the exponents, right? So I'm going to have a negative 2 times a negative 6 to get my new exponent for that a, and it would be a positive 12. And then I'm doing negative, for the b, I'm doing negative 5 times negative 6, which would be positive 30. So I do b to the positive 30 power. And then in my denominator, I'm doing negative 11 times negative 6, so I get c to the 66th power. And that would be my most simplified form there. Okay, so then the final rule says that what is a to the 0 power? So some number raised to the 0 will always be 1 as long as your base isn't 0. So it says for a not equal to 0. So if a is 0, 0 to the 0th power is actually is undefined. It's indeterminate form, but we're not going to look too much into that right now. So for our purposes, we're going to assume that our base is not 0 in order to then say that anything to the 0 is 1. So if we look at the example, we have negative 3x plus 7, all in parentheses raised to the 0 power. So it doesn't really matter what's inside those parentheses. As soon as you have something to the 0 power, we can say, oh, this must equal 1. And that's it. Okay? So now that you have this chart completed, we're going to look at a couple more examples that are a little more complex, that involve combining different rules together. So the first example has x squared divided by y, all raised to the negative 3 power. Okay, so first of all, when I have division raised to a power, both top and bottom get that, you multiply that exponent in, right? So my first step here would be to put that do negative 3 times 2 with the x. So on top, I'd get x to the negative 6. And on the bottom, I'd get y to the negative 3. There was no exponent with that y, or it was like an exponent of 1, so then just 1 times negative 3, which is still negative 3. Now, from here, I need to keep simplifying because I see that I have negative exponents. So again, if I want to get rid of a negative exponent, then I need to move the whole term. If it's in the top, I move it to the bottom moves to the top, and then I should be good. So the idea is because it's x to the negative 6, that's as if that is an x to the 6 in the denominator, and y to the negative 3 in the denominator is the same as a y to the third in the numerator. So then this would be my most simplified version of my answer. I can't do any sort of subtraction with the exponents because my bases are different. One base is a y, one base is an x. So I can only simplify that way if those variables match. Looking at example 2, we have 2cd to the 4th all raised to the negative 2 power times c times d raised to the 5th power. Okay, so there's no simplifying I can really do inside either parenthesis by itself, so I'm gonna move on to the exponents outside the parentheses, and the rule there tells me that everything inside, every factor inside gets that exponent. So kind of systematically going through, I should have 2 to the negative 2 power, c to the negative 2 power, and then d, the 4 times negative 2, so negative 8 power. So this exponent of 4 is only applied to the d. It's not with any of the other variables or numbers, so it's only being multiplied at that point. Okay, so that takes care of that first set of parentheses. So then times, I'm distributing now the 5 into the c and to the d. So that would be c to the 5th times d to the 5th. Okay, now I'd like to see, I do have multiple of the same bases, because there's a c here and a c here, and then there's a d and a d. So when you have same bases being multiplied, you add their exponents. That's one of our rules. So what does that look like for my, well, first of all, I'm going to take the number right in front, 2 to the negative 2. I'm just going to bring that down. I'm not going to deal with that quite yet. So then c to the negative 2, c to the 5. So I have to do negative 2 plus 5, which would be positive 3. So I get c to the positive 3. And for my d's, I have a d to the negative 8 plus 5. So that would be a d to the negative 3 power. Now I want to deal with, I don't want to leave an answer having negative exponents. So I notice that I have 2 sets of negative exponents there. I have the 2 to the negative 2, and I have a d to the negative 3. So any exponents I'd like to rewrite by putting as positive exponents in the denominator. So my numerator, the c to the 3rd, will stay where it is. And now my denominator will have a 2 squared times d to the 3rd. And the last thing I'll do is, I do know what 2 squared is. That's not too hard to do. 2 squared is 4. So this is c to the 3rd divided by 4d to the 3rd. And again, I can't really simplify between the c to the 3rd and d to the 3rd because those are different base values. All right, I have 2 more examples for you. So in example 3, here we start with a quotient with some division. And I notice I have m's on the top and m's on the bottom, n's on top, n's on the bottom. So I'm looking to try to do some canceling or to do some subtracting between exponents. First, I'm going to deal with the power raised to the power on top, because then once I know that exponent, I'll be able to combine it with the n's on the bottom. So my rule here is going to be to multiply 4 times 2, so I'd get n to the 8th power. And I'm just going to bring down my m and my n to, I already had an n to the 3rd, right? And then all over 2 m to the 2nd times n. Okay, so now I see, oh, I have n to the 3rd times n to the 8th on top and divided by another n. So I could kind of combine all that at once, which would be to say, like, 3 plus 8 gives me n to the 11th, right? And then I do, between top and bottom, n to the 11th divided by n, I would subtract, right? And I'd get an n to the 10th power. So then I know on my next line, I'm going to need an n to the 10th power on top. With my m's now, I have 1m on top and m squared on the bottom. So when I think about doing the subtraction there, oh, I'll highlight it down here on the previous line. Like that m on top is really like an m to the 1st power. So I'm doing 1 minus 2, and I get negative 1. Now, where does that m to the negative 1 go? Well, if I'm subtracting and I get a negative, I could put that right on top and say that is m to the negative 1, just like that. So that's one way I can do it. Or I could immediately put that on the bottom and make it positive. And I'll kind of do that in the next step. But now the only thing I haven't quite dealt with is this 2 down here. That 2 is just going to get carried down and stay exactly where it is. It doesn't combine with anything. So then now the last step I would do is deal with the negative exponent. Like I had just mentioned, I actually want that to be on the bottom if it has a negative exponent. So it would be n to the 10th divided by 2m. Now in example 4, we have an entire fraction raised to a negative 1 power. Whenever you have a fraction raised to a negative 1 power, remember that negative exponent is switching anything from the top to the bottom, anything from the bottom to the top. And essentially, like my other properties tell me that that negative exponent gets multiplied into every single term here. So a shortcut could be, instead of like actually doing out all that multiplication, is just to flip my entire fraction. So that would mean like the 3a squared b to the 3rd c to the 7th is now on top. And on the bottom would be the negative 2a to the 3rd b squared c to the 0. Now notice that negative 2 stayed negative, right? Because this exponent out front doesn't affect any sort of negative signs inside. The only thing it did essentially is like now we're saying we flipped everything. We put the top on the bottom on the top, and now we're saying that's equivalent to like this thing to the positive 1 power. Though we don't really need to write that because that doesn't actually impact anything. So I could just leave my answer like this moving forward and keep going. Now I'm looking to see what variables cancel on the top and the bottom. So I see for my a's, a to the 2nd and a to the 3rd, so 2 minus 3 is negative 1. Now I could save myself a step and then just say, oh, if I get a negative 1, that's like a positive 1 in my denominator, right? So that's an a to the 1st power. Or I don't even need to put that exponent and just say that's an a. I'm going to keep my numbers where they are because there's no common factor between them, so they're not going to simplify. Now moving on to b's. So for b's, I see b to the 3rd, b to the 2nd. So 3 minus 2 is 1, b to the 1st, since that's positive, it's going on top. And I don't really need to put the 1st power. For my c's, I noticed that I have a c to the 0. Well, anything to the 0 is just 1, right? So this thing is just going to become 1, and then it's not even going to show up anymore. And then on top, I have a c to the 7th still, so there's nothing to combine that with. So it just stays a c to the 7th on top. And that would be my final answer for this problem. All right, so now it's time for some U-tries. Here is 4 different U-try problems that get progressively a little more complex. So do the best that you can, and we'll be practicing this in class.